you're speaking their language when you're writing your application. And talk to your supervisor and your DDR or centre director where applicable. And obviously contact the Research Grants Office so that we can get the ball rolling with helping you as early as possible. So in terms of the procedure for applying for external grants, so there are a few steps to complete along the way. So there's an intention to apply form, which is a very brief half-page form that's sent to your DDR, your centre director if you're affiliated with a research centre or institute, and the research grants team. And what that does is advises of your intention to apply for a grant so that it doesn't require detailed information, but it's essentially a heads up. And by including your DDR and your centre director in that, those are people with the content specific knowledge that if you seem to be completely on the wrong track, hopefully they will jump in and catch you before you spend your valuable time preparing an application that might not be best suited for your research. In terms of notifying the research grants team, that allows us to prioritise and plan our workload so that we can make sure that we've got enough time to assist you with the application. So once you're at application stage, there's a project registration form that again is sent to your DDR and the research grants team with your application. That includes the key project information and the reporting information that we use in our research system. So things like FOR and SEO codes and so on. And there's a research project budget. So that is a specific internal template budget that we use. And it includes your proposed expenditure and the in-kind commitments. So what you often won't have if you're just preparing your own budget is something that allows your DDR or your supervisor to see your time commitment that may not be costed into the project. So those are the three mandatory forms that we have. This is a brief overview of the process. So as you can see there, the first step is that intention to apply step. So the whole point of that is the sooner we know about things, the sooner we can start helping you. We always recommend submitting your proposal to your peers, or at least a peer, to review, because obviously in the research office, we are not going to have the content specific knowledge to be able to assist you with that. So always engage with peers to help you polish and refine your proposal. Submitting to the Research Grants Office for review, we ask for that at least 2 weeks before the due date. We will then provide you with feedback and offer you any other checks or information that you need. You can then incorporate that feedback and finalise your application. And then it should be submitted to your Deputy Dean for Research and the Research Office at least 1 to 2 weeks before the due date. So the DDR will review the application and budget to ensure relevance of the program of research, and also that the school has the necessary means to provide support for the contributions of staff time, equipment or facilities that you've included. So the Vice President Research is the only person with authority to commit university resources to research projects. So that is why the VPR is the person that has to give that final approval on grant applications. So just some tips for beginners. So get the basics right. So just, it always amazes me when we have people applying for grants and they don't even know what the due date of the grant is. That's always the first question that we ask. So know what the deadline is and plan ahead. Get your team involved early. Make sure that you're following internal deadlines and processes, the external guidelines and funding rules. Make it count. So make sure that you're really demonstrating why you are the best person to do this project, why CQU is the best organisation to do this project. Demonstrate your capabilities. Make sure that you're justifying your budget. So a budget justification isn't just a description of the budget, it's why those funds are needed. Clearly articulate the benefits and impact of your project and get feedback. So in terms of the assistance that the grants team can provide, So we will assist you in accessing relevant documents. If there's an online portal that's used for the application, we'll help you with all of that. We facilitate legal review of contract terms and conditions, which are sometimes required at time of application, particularly with tenders. We're often asked to state compliance with contract terms and conditions even at application stage. We'll assist you with the required organisational information and documents that you might need, so insurance information, financial information, that sort of thing. We'll review your budget to ensure compliance with funding guidelines and CQU policy. We'll review your application to ensure compliance with the guidelines. Review the application to ensure that the key criteria have been addressed. We can proofread and copy edit your proposal, and we facilitate approval from the Vice President of Research. I've put a little asterisk down the bottom there on a couple of those items because if we receive something with very little time to spare, our capacity to really provide you with a lot of in-depth advice on things like how well you've addressed the criteria, proofreading and copy editing are obviously limited if we have very limited time to assist. So if we have limited time to assist, basically all that we can do is compliance checking, which is obviously not what we like to do. We like to add value and hopefully help you produce the best application possible. So that's it. So I feel like I've just about run out of breath there, but I think I tried to get through everything I could in that 15 minutes. So I think we'll open up for questions. I'm not sure how much time we've got, but we'll do our best.
Any questions for Christine and Mark?
No? Hopefully that means that everything was really clear.
Or else they're thinking about it and we'll come back to you at a later stage.
Sorry, Christine, can I jump in? Could you comment on the need for alignment with centres and institutes? Because I think that is sometimes confused, particularly in some of the initial forms that need to be completed.
Yes, certainly. So in terms of research grants and research projects, the alignment with a research centre or institute is based on the project, not necessarily on the staff that are working in the project. So we do have some projects that might be aligned with certain centres or research institutes where staff are not necessarily based in that research centre or institute, but they feel that the project sits well within the aims and objectives and the research focus of that centre and institute. So the reason for doing that is to try and concentrate our research efforts in areas where we know we have capacity and strength. It's not mandatory to align your project with a research centre or institute, but it's encouraged. So if your project doesn't align with a research centre or institute, there's always an option on those forms to say that it doesn't align and it just sits within your school. So in that case, rather than going to a centre or institute director, it will simply go to the DDR for review and approval.
Thanks, Christine. Any further questions?
Yeah, can I jump in again?
Yep.
This time, a question about the budgets and how these are put together. Again, could you expand a little bit on where and how that gets done, Christine, and what is done in your office and what is expected to be done in the school and by who? Thank you.
Right, so the budget, the template is prepared by our office. It is available on StaffNet. I'll send these slides through to Marilyn so that she can distribute that so that you have all those links. Researchers are expected to prepare at least a draft budget with their application. It's difficult for us to be able to start from scratch. Sometimes the form itself really scares people off, particularly if you're not used to Excel. So if that's the case, just get in touch with us straight away and we'll be able to work through it with you. What we sometimes do is just have, you know, a half an hour catch up with people where we go through the budget physically with them and step through it and start filling in some of those core details. Most people find that once they've done it once or twice, while the form looks scary, it's actually really quite straightforward. It's just a matter of plugging in how many hours people will be doing, the cost for equipment and that sort of thing. So it's a big Excel form with lots of tabs in it, but it's actually asking for quite simple information. But sometimes it is needed to just have someone talk through it with you. So that's part of what we do. And so we're always happy to assist with that.
Can I just throw in that I often find that it's useful for me to have a list of what I need money for first before I get to the raw, because often you'll find that you're trying to plan an RA across, you know, a couple of years or whatever, and so you need to work out how much of him you're going to put in year one and how much of him you're going to put in year two. And if you try and sort of work out what you're trying to pay for as you go along, you'll get a bit lost. So you make a list and then bring it across to the raw. And the raw's, Christine's right, the raw looks really scary, but it's not that scary. It's not that scary, is it, Mina? We've done a couple of them now. It's a piece of cake.
Yeah, and I think that's a really good tip, Michael, is to make a list and start there. I do have a separate presentation on budgeting that I'd be happy to do for the school that really does talk through a lot of tips and how to prepare and plan your budget. But that is a really good tip, to write everything down. And that's also a reason why when we're asked to review budgets, we will often have to go back and do another review of the budget once we've received the full proposal, because part of what we do is to read that proposal, look at your methodology. And for example, if in your methodology you've included surveys with participants, but there's nothing in the budget to reflect that. So there's nothing about either, you know, having to engage a survey provider, you know, reimbursements to participants, those sorts of things. So those are the things that will come back to you and say, hey, this is what your project plan says, but then your budget doesn't have anything in it about this. So those are the sort of things that we can also help with, because it is a bit of a skill, learning how to budget accurately for a project. A lot of people tend to sort of pluck a figure out of the air and work backwards from there. But that's not always the best way to do it, particularly when funding organisations expect a detailed budget and then you're held to account on that as well. So do just ask for help, I think, is my best tip on that.
Thanks, Christine. Any further questions? No, then I'll say thank you, Christine and Michael, and we'll now move over to our next session. And that is the RHD Student Presentations 2 with Amazon Web Services as the external collaborative opportunity and chaired by Biplob Ray. In your hands, Ray.
Thank you, Marilyn. I'm joining from a state of curfew. So it is good to be in this virtual school forum to get some human interaction other than family members. So today's session is organized with the theme of machine learning and distributed systems security. We'll start with, of course, the talk from AWS representative, Natacha Fort. She will go for 25 minutes and 5 minutes for question and answer. Then there will be 4 RHD students talk on machine learning and security for distributed system. Each talk will be for 5 minutes, followed by 2 minutes Q&A. So without further ado, I will invite Natacha Fort, but before she gets started, I will go through a brief bio of her. So Natacha is a machine learning specialist solutions architect based in Sydney, Australia. She helps organizations navigate their machine learning journey, supporting them from framing the machine learning problem to deploying into production, all the while making sure the best architecture practices are in place to ensure their success. Drawing on experience from her previous role as an AI/ML architect in a consultant firm, designing and implementing machine learning projects in a wide range of industries, from telcos and retail to governments and healthcare. Natacha aims to support organizations build scalable, reliable, secure, and cost-effective machine learning solutions. Natacha works with organizations on problems around computer vision, natural language processing, among many others. So please welcome Natacha with the talk, Machine Learning Research on AWS. Thank you, Natacha.
Thank you, Ray, for the intro. Hi, everyone. I'll share my screen to get started with, and let me know if you can see. I'm not overly proficient with Zoom, so I'll do my best.
Yes, we can see the slides.
It's all good? Okay, perfect. All right. So today, I wanted to talk about AWS and some of the services that we offer specifically around machine learning, and some of the tools that we have that you could consider using. And specifically, I wanted to start with this image that's been taken by the latest rover that's been sent to Mars, this Perseverance rover. It's all the telemetry and all of the data is actually being transmitted from Mars to AWS directly. And all the analysis and the machine learning that is being done on that data is happening on AWS. So it's our first interspatial mission, so it's really, really cool, something that we're very proud about. But I thought I would be interested to get started with this. So the agenda for today, it's going to be quite short and to the point. We don't have a lot of time, so what I'll do is I'll talk about the current state of AI and machine learning, more specifically why we're doing machine learning at AWS and where this is coming from. I'll do a bit of an intro on the tools that we have available to do this machine learning, and more specifically, I'll do a quick demo, depending on how much time we have left. I'll do a quick demo of some of the new tools that we released, where it's really, really easy to go and do machine learning and to scale. So to get started with, today, I wanted to talk about why AWS does machine learning. Well, if you think about Amazon, so AWS, as you might know, it's a subsidiary of Amazon, right? And Amazon is this big retail company that sells products online. And Amazon is this example of this company that went through a multi-year machine learning journey where it's really been a journey to become a machine learning driven company that you can see today. We've been applying machine learning in areas like, for example, personalization. So when you log in the website, for example, and you can see products that are recommended to you, you have this type of personalization. We've applied machine learning in the supply chain, for example, for forecasting. And we've done that over the years for many, many years. So we started more than 20 years ago with things that were very classic, so statistical machine learning methods, and moved on over the years to more advanced methods, so things like deep learning. And we not only advanced the technical side of things, but what we did was apply things that we were doing in one area. So for example, personalization on the retail websites, and applied it to many other areas. So for example, we have also a subsidiary where we recommend, we have this Prime website where you can stream videos, and we do recommendation on there as well using the same algorithm that we use for the recommendation on the retail website. And over time, as I said, we've improved those methods, and we're doing things today like natural language processing, for example, with Alexa. We're doing things like autonomous flight drones, which is pretty cool. And doing machine learning everywhere like that was really a big culture change. But it's something that we think every organization can do. And that's why we say that our mission at AWS is to put machine learning in the hands of everyone, of every developer, every data scientist, and every researcher. And that's what we're trying to do with these tools and the services that we have available for everyone. So in terms of how we see the technology that we offer to our customers today, there is these three different stacks. So as you can see on this slide today, so we have at the top level, we have what we call these AI services. Those are the services where you don't really need the machine learning experience. They're super easy to use. You just send some data, you're going to get some insights. out of that data, but you don't need to train a machine learning algorithm. It's all done for you. It's all managed by AWS. And I wanted to start by giving you a few examples of some of the things that we have in that space. So for example, we have a product that is called Amazon Comprehend Medical that is able to process medical information and extract insights out of that medical information. And I actually wanted to show you what that looks like on the console because I think it's quite cool. So if I can just drag this window back here and show you. If I show you Comprehend Medical, so this is the AWS console. And if I navigate to Amazon Comprehend, and I navigate to launch Comprehend Medical, I just want to show you the type of analysis that it's able to do on text without training a machine learning algorithm, just because I think it's quite advanced and it's quite impressive. So this is a piece of text, as you can see here, and it's describing the conditions of a woman. So as you can see, there is lots of text that is the natural way that a doctor would write this text. So there is some abbreviations, for example, there is numbers in there. There is terms that are very medical specific. And so if I analyze this text using this Comprehend Medical tool, the type of analysis and insight that it's able to extract is going to look like this. So as you can see, it's able to, for example, extract the date. So know that a certain piece of information is a date. It's going to know everything that has to do with a medical domain. So things like, for example, symptoms. So like palpitation, for example, it knows that it's a diagnosis names, chest pressure, it's got an organ name with this chest, but it's also a diagnosis, and it's able to determine all that. And it's also able to see, as you can see here, for example, in the text, the relationship between the different pieces of text. So for example, here we have some medical dosage, and it's able to see the frequency that it's, or specific medication, you can see the frequency that is related to this medication, the dosage, etc. And it's all able to figure this relationship and this insight out of the text. So you can get this really, really rich information on which you can then build application of. So that's an example of one of the those high-level services that I talked about, that they do machine learning, but you don't have to worry about it. Then we have the next level, which is generally the level that's very, very interesting for researchers. Let's cover that up, which is this level. This level is called Amazon SageMaker. And that's where you actually get to do the machine learning yourself. So that is where we support the end-to-end machine learning lifecycle. And we enable researchers and we enable data scientists to go in and say they want to train an algorithm that is going to detect cats on images. We give you the ability to, first of all, try some algorithm that we have set up for you, but you can also decide to write your own algorithm. And we give you the ability to use infrastructure without having to think about things like networking or scaling or security, all of that being managed for you. So for example, say I have a petabyte of images of cats, and I want to train an algorithm on this petabyte of images of cats. Then I'm very easily able to set up a training cluster at this level. And I don't have to think about networking or any of that. It's all going to be done for me. I'm just going to pass my algorithm, and that's going to be managed for me. And as I said, we cover the end-to-end machine learning workflow. So it goes from everything that has to do with preparing the data, so labeling the data, applying those transformations that we typically apply when we do machine learning, up to the point where you've trained an algorithm, you're happy with it, and you want to deploy that maybe in a production environment. So this layer is called Amazon SageMaker. And as I said, we cover the end-to-end machine learning journey. Now there is another layer, which is this bottom layer, which is basically the servers, those virtual servers that we give you access to. But there is a few things that are a bit specific to machine learning. So for example, we have specific images like TensorFlow images or PyTorch images where the frameworks are already installed, the machine learning frameworks are already installed. But we also give you access to specific infrastructure, so things like GPU or things like what we call inference chips, where you can, once you've trained a model, you can deploy that model and you can do this inference at a very low cost and very efficiently. So this is the last layer. And today what I wanted to do is spend a bit of time and tell you about this Amazon SageMaker, this middle layer of the stack, because this is the layer that we see lots of researchers today use and a lot of data scientists. So as I said, it covers the end-to-end machine learning journey. So it goes from labeling the data to collecting and preparing the data. We have a feature store, which is when you already applied your transformation to your data, you might want to store that data and be able to reuse it whenever you want. We have the ability to access notebooks, manage notebooks, where you don't have to think about the infrastructure. You can just go and with a few clicks, you're going to have a managed notebook where you can write your code and where you can write your experiments. And then what I think is very interesting when you're doing research is the ability to train model, the ability to tune parameter at scale, of course. So it's when we're talking to researchers, typically that's one of the issues that they have is that they need to be able to access those HPC clusters, right? And there is a long delay typically, especially at those conference times, to get access to those HPC clusters. And that's where we give you access to that training capability within the cloud, where you can go and you can access a massive training clusters instantly, and you don't have to wait. It's already available. So that's one of the things that we see lots of researchers use today to be able to scale the on-premise cluster that they have on site. And then the ability, of course, to deploy once you've trained that model, deploy it, monitor that model in production. If you have applications that you're managing, you might want to monitor that model. And finally, be able to do everything that has to do with CI/CD, which is typically not too much of a concern for research, but it's good to know that it's there if ever you work in an enterprise context. So in a bit more detail, these are the different products that we have. So within SageMaker. So as you can see, there's lots of capabilities. So we won't be able to go through lots of them today. But what I'll do is I'll focus on one of them that is called Data Wrangler, which is this one, which is in the prepare stage. And this Data Wrangler is actually a tool that enables you to prepare data very easily in a visual way. So it's a graphical tool where you can very easily apply transformation to your data. But there's also lots of cool capabilities like being able to visualize the data. So being able to, in a few clicks, just do some histograms, for example, but also the ability to train a quick model to see if you're going to have any outcomes or any results on your data without having to start and do all that process through coding. So that's what I'll show you today. And for that, we'll go through this demo, which is end-to-end machine learning on tabular data, where I'll show you how to do this preparation, this visualization, and training a very quick model in order to get these very quick results to know if the problem that you're trying to solve is actually solvable. So the data that we're going to work on is data from the Titanic shipwreck. So it's data that has demographic information on some on the passengers. So it's got information like, for example, the sex, the age of the passenger, the ticket class that they had, and most importantly, if they've survived or not. And what we're going to do in this demo is actually try to, first of all, do some preparation on the data, and then try to train a very quick model to know if the passenger survived or not. So that's what we'll do. So let me share, I'll switch my screen for a second. Here we go. Just need to zoom out. Okay, so we are back on the console, the AWS console. And the first thing that we want to do is navigate to SageMaker. So the way I do that is through the search bar at the top, where I'm going to type SageMaker. To navigate to SageMaker, for those who haven't done it, this is the easiest way to navigate in the AWS console. And then I can navigate to SageMaker Studio, which is this managed Jupyter environment that we're going to use today. So it's basically it's a Jupyter Lab environment. For those of you who aren't familiar with Jupyter, it's a place where typically data scientists or researchers would write experimentation. And the idea is that you can write some piece of code, but you can also write some documentation on that code and create this narrative that is pretty nice. So I'm going to open Jupyter, and to do that, the way to do it is to click on Open Studio, which I've already done. So it's just going to open. Already done it here, so I'm just going to jump to that. So this is SageMaker Studio. So as you can see, if I just show you the launcher, which is the thing that you get when you just log in the first time, this is what it looks like. So you open, it's basically a Jupyter Lab environment where you have a lot of components that we added on top of it to make it this complete tool for machine learning. And this is an example, just want to show you, this is an example of a notebook that I was talking about where you can write this code and you can mix it in with some text and some explanation about what's happening. So I'm not going to go in detail around that. But within this SageMaker Studio, if I navigate to the bottom here, you can see the SageMaker resources, and that's where I have access to a number of SageMaker specific components. And today we'll look at Data Wrangler. That's what I'll open. And what I'll do is I'll create a new flow, but we'll process this Titanic data. So I'm going to open that. That's going to take a minute. Once this is connected, the idea is that the first thing that we'll do is load some data. So load that Titanic data. And our data is going to be stored in what is called Amazon S3. I already have one open. Okay, very good. So this is what happens when you load Data Wrangler. So my data I know is in S3. S3, you can just imagine it's a big folder in the cloud. So that's where we're going to go and get the data from. So I have lots of folders in there. I have one that is dedicated to Titanic. And I'm going to use this train.csv data. And so I can have a quick preview of what the data looks like here at the bottom. So as you can see, there is different columns. There is, for example, the name of the passenger. You can see here the sex of the passenger, their age, the ticket class, but also if they've survived or not. So I'm happy with the data. That's the data that we're going to use. So I'm going to import it. And that's creating a flow. Now, in this flow, that's where I can go and add transformations. So if I click on here, first of all, I can choose to edit data types because the types in the data, like for example, if it's an int or if it's a string, this is something that Data Wrangler figured out by itself. So if I want to, I can go and edit that. But say I'm happy with it. The next thing that I can do is add transformation. So lots of transformation in machine learning. There is a few obvious ones that we can do here if we want to be able to predict that survived column. So to predict if based on the demographics info, would a passenger survive or not. The first one that I think of is, for example, getting rid of the name, because we want to be able to determine if the passenger is going to survive based on demographic, not based on a specific passenger. So let's apply this transformation where we want to drop the name. So I'm going to click on Manage Columns. Here you can see all the transformations on the side. So in this case, we're going to drop this name column. I can preview. It's deleted my column. I'm happy with that. I can add this transformation. Okay, pretty good. Another transformation that we typically do in machine learning is, for example, being able to encode categorical variables. And so here, for example, we have the ticket class, which is a categorical variable. And so same again, if I want to do that, it's very easy. I can go here on encode categorical. There is a number of options that I can select. There is over 300 transformations available in Data Wrangler today. So we cover most of the typical machine learning transformations. So I'll select P class, and I'm going to select colon as the output style. I'm going to do that. Say I'm happy with that. I'm going to add that transformation as well. Okay, so now if I go, you can see that the P class disappeared. And if I go to the end of my data, you can see that there is 3 new columns. So I encoded this categorical variable in 3 new columns, class 1, class 2, and class 3. So I've done this transformation. If I want to, I can add custom transformations as well, with writing Python code, using PySpark or using Pandas, depending what tools that you're familiar with. And then say, there is a lot more that I could do. So for example, you see that there is some missing value that we should deal with and all that. But let's say that at this point, we'll just keep it that way. We're happy with that. And what I want to start and do is, if I go back to my data flow, start adding some analysis. So one of the things that I can do is, for example, create a very quick histogram on my data. So I have my data that's here at the bottom. And say I want to view the passenger who survived. I want to see by age and by sex what that looks like. So we're going to look at survived versus age versus sex. So at the x-axis, I'm going to select the age. We're going to color it by survived or not. And the facet is going to be the sex. So if I create this visualization in just a few clicks, here you can see, just zoom out a little bit. You can see this visualization has been created. So you can see on one side, I have my females. On the other side, I have my males. And the passenger who survived are in dark. So you can see that actually a lot more female survived than male, which correlate with the movie story that we heard about. So yeah, that's the idea for the visualization. So just a few clicks to create those. And the last thing before I finish here that I wanted to show is that you can create those quick models. So if I go on the side here, I have this analysis type. I'm going to select quick model and say I want to predict if my passenger survived or not. I just need to specify this is the level that I'm trying to predict and click preview. And that's actually going to train this quick model. It's a quick and dirty model. It's not something that you might want to use in production, but it's going to give you an idea of if what you're trying to do is going to work. And so that's going to take a few seconds, and it's going to train a model. And now I can see that the model achieved 0.8% F1 score, which is a metric that we use to judge how good a model is. So it's a pretty good score for considering the amount of preparation we did on the data. So we know that's a problem that's probably solvable. And you can see as well here the feature importance. So what are the features? What are the specific columns that your model is using to make this decision? And you can see that the first one, to know if the passenger survived or not, is the sex. So it's using this one as the most important feature to determine if a passenger is going to survive or not. So that's the idea for Data Wrangler. And that's just one of the tools that we have in the set of tools available on AWS. This one is really much about doing quick experimentations. Now we have a lot of things that are about scaling, which is a lot less exciting to show in a demo like this, but also very interesting for researchers. So if you are interested about those capabilities, I'm happy to dive into it at a later point. But that's pretty much all I wanted to show you today. And I just wanted to wrap up on, let me just switch displays. Yeah. Just wanted to wrap up on, first of all, a quick customer story. So for example, to give you an idea of how quick it is to build machine learning and to scale machine learning in the cloud today. We have customers like, for example, Moderna with the vaccines that have been able to do this experimentation at scale very, very fast, thanks to the cloud, because they were able to access the infrastructure right away, and they came up with a first design for the vaccine. I think it's something like 42 days being able to use cloud infrastructure. So pretty cool story in terms of you know, the speed that you're able to achieve for the innovation. So if you want to get started today, we have lots of tools available online. So things like Deep Racer that you might have heard about, that, for example, enable you to learn about reinforcement learning, which is a specific domain in machine learning, and you can train your own autonomous car, but also lots of other tools that are available out there to help you get started. And we also have lots of videos and content out there in terms of training that's available, for example, in the Coursera platform to scale you up. So that's pretty much all I wanted to cover today. I'm happy to take questions if we have time.
Thank you very much, Natasha. We do have 4 minutes, and thank you for finishing on time. We do have some questions in our chat box, but I will ask everyone here to ask first before we go to the chat box. I see Michael has his hand raised. Michael, please go ahead.
Hi, Natasha, thanks for that. That was awesome. I haven't done anything in this area for a long time, and it's really interesting to see how it's moved on. I was particularly interested in the Comprehend tool that you were talking about, because I was actually talking to a nursing student who was talking about how useful it is sometimes to have that data summarized, especially when people first come into hospital. And so I was looking at that going, wow, this is kind of exactly what she was saying. Can you then take that data, let's say it came in through Alexa, and then you did a Comprehend or Lex, and then you used Comprehend to do the analysis that you showed us. Can you then take that data and analyze or summarize that data the way you were doing with the SageMaker data?
Yeah, there's different options there. So for example, as part of Comprehend, so I showed you this piece that's Comprehend Medical, where you're able to extract entities, for example, that are specific to the medical domain. There is also a feature that's about text summarization, so where you pass a big piece of text and it's going to try and give you a summarization of the text. And yeah, there is different capabilities around natural language processing. So yeah, it's definitely, I think, lots of things that are achievable today without going too deep into the deep end of machine learning. So yeah, if you're interested to talk more about the use case, I'm happy to help you with that.
Is there a way to just get in and muck around with the system that you're talking about?
Yeah, for sure. So if you just create an account by yourself, you should have some free tier. So okay, you should be able to use the services for a certain amount of hours for free. But also if you talk to CQU, I think they might be able to provide some accounts with some limited credits, maybe. I won't commit to anything, but maybe something to investigate there.
I will do. I've got lots of Alexas, but have never done much with AWS. So yeah, might be a project. Thank you so much for that.
Oh, no worries.
Thank you. Nahina.
Thanks, Ray. Thanks, Natasha, for the very useful presentation. I just had one question. So firstly, to mock around, we can just open an AWS account and have a free trial, right?
Yeah, so for example, with SageMaker, you have I can't remember the numbers, but hundreds of hours of free like notebooks to run and this sort of thing. So there is a big free tier that is available for, I think, the first few months that you use the platform. So if you want to muck around with it, you can use that. For students as well, we have this platform that's called, this program that is called AWS Educate, where students can get accounts with some credits on there to do some experimentations for free.
Fantastic, thanks. And the other question I have, when we're training the model at SageMaker, can we save the training model, I mean the training data, so that later on when we have new parameters, they can be classified automatically using those training data, or do we each time have to manually train them?
No, so everything is, the idea for SageMaker is that, first of all, everything that I showed you and more is available through an API. So everything is meant for automation. So say, for example, you have data, your data, when you use SageMaker, is going to be stored in S3, your training data. Say you want to train an algorithm once, maybe you're going to go in there, you're going to write your Python script where you're going to say, hey, I want to run a training job on that data. And here is my TensorFlow model that I wrote. Please train that. So you're going to set that up manually once. Maybe you want to do that every time you have new data that is coming in the platform, or whenever you push a new code change, you can automate that. So for example, every time you have new data coming in, you can trigger retraining automatically. And then every time you train a model, there is a model artifact that is coming out of that. So for example, if you're doing TensorFlow or PyTorch or scikit-learn even, it creates this model output, right? This file that is your model. This, you can access it and you can decide to deploy it wherever you want. So that could be on premise if you want to. It's in the same format that we were training it on your own, say, laptop. But you can also decide to deploy it in the cloud. And then when you have inference data that is coming in, you can have this inference happening automatically. So yeah, there is definitely ways to automate all the different parts of the machine learning lifecycle.
Thank you.
Thank you.
Thank you, Natacha. This is the last question, and then we'll move to the student presentation. Mohesh asked in the chat box, what about the featuring engineering? Is that also the part of the SageMaker?
Yeah, so there is this. So there is one part of it where with the tool that I showed you with Data Wrangler, where you can do some feature engineering there. So you can do some transformation of your data, featureization, depending on what you want to do. You can also, we also have something that's called a processing job, where if you need to apply this transformation at scale, it's not only available for training, but it's also available for the pre-processing of your data. And that means that because typically you would have different infrastructure needs for the different parts of the journey, you can really specify, hey, I want to run this pre-processing on my data, and I want to use these machines that have these big CPUs and a lot of RAM. And then later on, once my data is prepared, so I'm doing that for a processing job. Once this is done, I can move over to a training job where I'm going to take that data that's been pre-processed and I'm going to run it maybe through a machine that has a GPU. And that way I'm very efficient with the infrastructure that I'm using, and meaning I'm very efficient with the costs.
Thank you very much, Natacha. We will just move to the next presentation, but before that, put your hands together for Natacha. Thank you very much.
Thank you.
Varun, Chandrappa will present the next talk on topic smart irrigation management model using intelligent Internet of Things. Varun,
yeah,
over to you.
Yeah, I'll just thank you. I will share the screen. Okay.
Yep. Just make it slideshow and then go on.
Yeah. Okay. My name is Varun, and the Biplob is my principal supervisor, and Ashwath Nanjappa is my associate supervisor. Today, I'm going to talk about smart sensor system for Keynes Park management, for smart water management system, which is implemented in a Keynes. The main components which are involved in this is data collection module, and a data accumulation module, data abstraction, and decision making. In the subsequent slide, I'm going to discuss about the architecture, wherein I will cover entire each component in detail. Okay, it's loading. Okay. In this particular park, what we have done is we have installed 4 sensors at a different depth of soil. One is at 10 centimeter, 30 centimeters, and 90 centimeters, and another is at 120 centimeter. The depth is selected based on the type of plant is growing in that particular zone, and as well as the root depth. Based on that, we have selected the different depth of sensor installation. These sensors sense the current soil moisture in volumetric moisture content to a gateway using LoRaWAN protocol. Apart from that, we have also installed a local weather station which can monitor around 17 parameters, and those 17 parameter details also will be sent to the gateway using a LoRaWAN. From this gateway, we are transmitting the data to the Things Network cloud. From the Things Network cloud environment, we are pulling it into a ADC cloud platform using Node-RED application. In the ADC platform, we are storing the data in a InfluxDB, which is a time series database. To the time series database, what we have done, we have plugged in a chronograph and as well as a capacitor. The reason for plugging in chronograph is to give visual representation of the data. And it also has a many feature wherein user can filter the data based on what he needs. Apart from that, capacitor, which is used for alert. If there is an anomaly is detected, or if there is any problem in the sensors, or if the moisture level goes above the predefined level, then it will automatically send an alert to the configured user. These are the ways which we have done the alerting mechanism. Apart from that, what we have done, we have implemented a machine learning algorithm using which it pulls the data from the time series database and analyze when to sprinkle the water or when not to sprinkle the water. Once the decision is made, using MQTT protocol, it sends the data to the actuator. In the actuator, we'll either turn on the sprinkler or turn it off the sprinkler. Apart from that, this machine learning algorithm also does forecasting. What it does is, if this is the current moisture level, what is going to happen in 1 hour? What is going to happen in some days? That is what we are going to forecast it. Okay. Slowly. Okay, little it loads. I will continue. We have done a lot of analysis on using various machine learning algorithm. We have found out that all the algorithms has performed really well. But only thing which we noticed is these algorithms needs a larger set of data when you are doing the prediction. So what we are doing, and also what other thing which we observed is, when you do a prediction based on the soil moisture sensors, what we have to do is we need a larger number of sensors needs to be deployed in the park. That will increase the cost of overall project. What we have done is, what we are planning to do is, we are planning to do an extrapolation using transfer learning mechanism. What this transfer learning mechanism does is, using the minimum set of data, we are extrapolating to a larger quantity, how the soil moisture is distributed in the entire park. Okay, that is what one of the things which we are planning to do it, and it is still in the research state. I'm not sure why is it screen loading is taking too much time. Okay, this is the graph which I wanted to show it. When we implemented this particular project in Keynes, what we need is, these are the social contribution which has been done using this project. The main thing is sustainable environment, using which what we are able to, using with this project, what we can able to achieve is, you can reduce the water usage and reduce chemical leaching and optimize the fertilizer usage in the park. And also we reduced the water drainage, and this project also improved groundwater level. Apart from this, when we are planning to implement extrapolation using transfer learning algorithm, it reduces the number of sensors. When it reduces number of sensors, it reduces the cost of the overall project and gives automated control to the council, and reduces maintenance costs, and it will maintain the park in lush green and increases the crop yield and protects the Great Barrier Reef. What was happening here, because of chemical leach, it was entering into the sea and it was damaging the reef. Since we are controlling over irrigation, this will also be going to be reduced and it saves the Great Barrier Reef and reduces public complaint on wet and dry condition. As of now, we have analyzed this, and after deployment of this particular project, we have analyzed the water saving for particularly for 130 days. We can see that old watering system is this much is the water usage, and currently it is significantly reduced for 1 month. And it has been monitored only for the 2 stations. If you can go to Keynes and explain it, there are around 250 stations. So this only with the 2 stations we can able to achieve significant reduction of water usage. When you compare for a whole park, the water saving will be significant. Based on our research study, what we found out, there are some weakness in the existing sprinklering system. We analyzed this weakness and we come up with a solution, and it has been patented in Australia. And this is the patent details which is filed in Australia. And we also published one paper on smart irrigation, and some of journals and publications are in pipeline. And future research direction. In order to achieve better result in our particular project, we need to have a continuous connectivity. So gateway needs to be a fault tolerant, which is one of the things which needs to be, some research has to be carried out to improve that. And apart from that, we have faced a lot of problems related to durability of the sensors. And that also one thing which we have to taken care, someone has to do research on that. That is waterproof related problems and power issues and cloud interface. Specifically, if you can see in our case, we are using TTN, Things Networks, and as well as ARDC cloud. There are a lot of things we need to face problem when we are migrating from one cloud environment to another cloud environment. That is one of the problem which we have faced. And the communication issue, when the data is transmitting, a lot of times we are facing a problem of connection failure. That is one thing. And when we are connecting heterogeneous devices, for example, weather data and soil moisture, the connection will be a big challenge because it's in a different manufactured by a different vendor. These are the areas which we need to have some research to get a better result of this particular project. Thank you.
Thank you, Varun. I can see our Dean Steve Hall has raised his hand. Steve, do you have any question?
No, and I didn't know my hand was raised. I'll take it then.
Probably a fault of an AI. There are a few questions on chat box for Varun. The first one is from Mohesh. How did you handle the data drops in route from LoRaWAN to message queue in cloud?
Okay. There are certain times which we noticed that, see, we have a inbuilt memory storage in the node. If you can see here, let me open this slide. Okay, this is the node which has a inbuilt memory storage. If sometimes what happens, due to communication, some packets might have dropped or some data might be missed. Using this inbuilt memory storage, we are storing the data here. If there is a data loss, we can still extract the data from here. That is how we manage it. I think, is it answered your question?
He also asked, what algorithm did you use to handle such dropouts, noise, and so on?
We have used around 5 machine learning based algorithm and 2 statistical based algorithms. Statistical based, we have used Z-score and IQR, and I can see there are quite a significant amount of machine learning algorithms we have used it for handling the noise. But one thing which I can point out, isolation outlier this is the one which has given a better result for us, because here the outlier, the noise is not only at the extreme end, and there will be a significant noise in between. So that handling is also very important in our case. We failed. Isolation outlier has performed really well when detecting the in-between outliers.
Thank you, Varun. Due to time, we should move to the next presentation, please. And you can have your discussion offline if you want to continue. Susnata Bhattacharya will be the next presenter. He will present on dynamic log parsing framework for failure prediction of Internet of Things gateway. Susnata, all yours.
Yeah, thank you very much, sir. And thanks everyone for providing me this opportunity to share my project. Let me
go to slide share, please.
Yeah. Okay. Yeah, so my research topic is dynamic log parsing framework for failure prediction of IIT Gateway. I'm working on this project under supervision of Dr. Biplob, Dr. Ritesh Chugh, and Dr. Stephen Gordon. At the outset, I just wanted to give a sort of a brief overview of what the model is and what are the features of the model. And the study is actually based on IIT LoRaWAN Gateway log parsing framework, which is based on neural OpenIE and pre-trained dynamic word embedding techniques. And it's a part of the natural language understanding processes, rather, which can actually parse online streaming system logs. So if you look at the current SOTA and the current literature, most of the models have kind of focused on predefined template-based offline models, but we kind of avoided that and kind of moved towards more of a data-driven approach, where logs can be actually monitored and analyzed in real-time scenarios. So what exactly is OpenIE? So OpenIE is a process of generating structured representation of information from large text or web corpora. But we kind of tried embedding that process with log parsing as well. And this is something very unique, because we haven't come across any models which have talked about embedding OpenIE and word embedding techniques within log parsing processes. So further to that, what we have tried doing is we have tried embedding contextualization so that the system becomes more context aware. And for that, we have leveraged dynamic word embedding models instead of taking the traditional the static word embedding structures. And the model is it's at a very nascent stage currently. So we have just developed the mathematical model, but we are kind of as a part of the future progression of the research, we are going to focus on creating the model more robust in terms of the algorithms that we're going to use and define the model properly. But yeah, it's just the mathematical representation and at a very nascent stage currently. Yeah, proactive failure prediction of cyber physical systems. So it can be, it's an agnostic model, so you can use anywhere literally for log parsing and analysis, and any CPS models can be actually monitored and made them fault tolerant. And that's what the future goal is, to make it just not a fault detection mechanism, or an anomaly detection mechanism, but focus more towards failure prediction scenarios. And we have moved away from the traditional machine learning models, but kind of imbibed on the deep learning processes, so that we can increase the prediction accuracy and effectiveness of the model than the ones that are currently available in the literature and the SOTA. And the proposed model is actually has two distinct modules. Rather, it's a modular structure. So the first part of the framework is actually where we used triple sets or generated log triples from using neural OpenIE. And the second part is an encode-decode architecture, which kind of mimicked sequence-to-sequence operation like traditional RNNs and LSTMs, which kind of does that process for our time series data, but we kind of leveraged an encode-decode architecture so that it can be handled more parallelly and more faster in case of time irregularities scenarios. So this is kind of the partial framework design. So the failure prediction is not included in this. This is just the log parsing framework. So at the extreme left, we have the gateway layer. So the gateway layer is actually basically, as Varun was also alluding to, it's the middle tier or the edge device, which kind of sits in the middle, and the sensor clusters gets connected to the gateway, and the cloud or the things network sits on top of it. So gateway plays a very important role, an essential role in such networks, and it is absolutely important that we monitor those gateways and and devise mechanisms to proactively detect failures, so that proper mitigation sort of steps can be taken to avoid such failures and have a high availability sort of solution within the environment. So the extreme left, as I said, is the gateway layer. So now what happens is if the gateway kind of reboots, all the system logs and all the other firewall and packet forward logs gets washed away. So we had to bring in another level of log accumulation here in this section, where we have two stages. One is the online stage and one is the offline stage. So the offline stage is basically where the logs are accumulated, and it's used for training, validation, and testing of the model. And we kind of embedded our trigram solution using TF-IDF vectorization approaches, so that we can create relational tuples out of it.
And sorry, then last 1 minute due to time, please.
Okay, and these features are the dimensions of the features are kind of reduced and saved in a vocabulary data set. So that's basically just the log parsing framework, but we are kind of working on the failure prediction part as well. On the next one is, so in terms of social contribution, yes, it's a solution which provides fault tolerance of any CPS systems. And it's a lightweight solution because we're using the pre-trained dynamic word embedding techniques, which kind of, does most of the backend works of, handling the robust data analysis. And the only thing that we have to do is kind of hyperparameter tuning and basic, weight adjustments, which would provide the sort of data that we're looking at. And it's a multiple it's a domain agnostic process, so we can use in power systems, we can use in healthcare and smart city and any sort of traffic control systems and so on. And it's definitely an add-on layer for the mission critical systems in terms of proactive monitoring. As I said earlier,
Susnata, I will just say your time's up, but thank you. It's a nice presentation. It's just that because of that time, and of course other presenters are queuing up. Thank you very much. And for question and answer, I would request we bring it at the end because we have other two presentations to go through. Thank you, Susnata, very much for your presentation.
Thank you so much. Thanks.
Next presentation is from Robert Buhrke. Robert will present on forget those password and fingerprints, advancing information security and privacy for users of smartphones, smart devices, and IoT applications. Robert, to you. Susnata, unshare, please.
Good. Thank you very much.
Susnata, unshare, please. Your shared screen, please. I hope he's still there. Can't share his screen. Okay. Robert, on you.
Good. Thank you very much. My apologies for having to wear the mask. I'm at the airport, just about to board a plane to legally escape the lockdown here in Darwin. So apologies also in advance for any noise that may come up, which I can't stop. I can't get out of here at the moment. So a little bit of an overview of what the actual problem is, what others have done, where the research gap is, the research method, and the next steps. Quick question, can you hear me okay?
Yep, we can. Are you planning to share any slides?
Sorry?
Are you planning to share any slides or presentation?
Yes, I am on screen sharing.
Yep, we don't see it yet.
I might stop and try again.
Please.
Can you see the slides now?
It's all good now. Okay,
good. My apologies. Good. So essentially the core problem, particularly with passwords, passwords as a main form of authentication is that they're relatively easy to get for adversaries, and they're relatively easy to forget. And if normal able people with a well-functioning brain have trouble remembering passwords, it becomes even more difficult for people with disabilities. So from a social impact perspective, passwords are not necessarily the best solution, especially when people have, for example, Alzheimer's or dementia, other challenges. So biometrics is an even bigger problem. Fundamentally, the main challenge is what happens if the data gets into the wrong hands. And there have been quite a number of cases where biometric databases have been completely open and unsecured on the web, where people could download personal identifiable information, including high-resolution original fingerprints, iris scans, and high-resolution photos. So this led me to investigate what others have done, what other methods are out there. That was part of my literature review and ongoing investigation into alternative solutions. So MFA, multi-factor authentication. Many of you would be familiar with tokens in the past, maybe dedicated keys. And then there is a whole overview or different elements that are hardware tokens and smart cards that are used, largely in defense and high security systems. The field of biometrics is continuously evolving. I'm not totally against biometrics, but it does have some challenges. And generally, when we talk about authentication, for example, machine-to-machine authentication, for example, a drone flies to a recharging station, this is not an application for biometrics because there is no living object involved. And then there are combinations of the above and a number of exotic ones. So as a bit of an overview, I'm not planning to go through all the details. You may not be able to read this, but fundamentally, we can classify authentication methods by type. For example, so what you know, knowledge-based factor, what you have in your possession, what you are, so the inherent biometric-related areas, and for example, the type 4, where you are when it's location-based. And each method has a number of advantages and disadvantages, but fundamentally, the most advanced and secure methods are largely left for defense or high security applications. The mass user adoption is relatively far away, but this opens up some exciting research opportunities. So I want to give you one example, since we're all in IT. Many of you have probably heard of so-called hardware security keys. There's a company called Ubico, probably the most famous and most widely adopted one. So the essential concept is that you're using a so-called authenticator, so a device that provides a level of abstraction between the actual person and then the client or the device that you use to then authenticate to a particular relying party. This model has received very good research reviews. It is exceptionally, let's say, reliable. I use it on a daily basis. And this is certainly one step in the right direction. So if anyone is looking for more secure ways to authenticate, this is the status quo that I can definitely recommend based on my research. However, there's still a need to actually plug these devices in or hold it close with NFC, and those only work with online services. A little bit of an overview on what we're all familiar with. Obviously, with the university, with standard logins, it's the username and password, and then there are various other devices that are quite familiar. Some of you, I'm sure, would have been using authenticator apps, which is not a bad solution in itself, but it adds another layer of complexity. Just as an example, actually breaking down the analysis between, for example, the conventional methods as a password versus some of the newer methods. Other researchers have broken it down into usability, deployability, and security. My research focus also on an aspect of privacy, which is directly related to some of the newer concerns, privacy and security, are tying into each other there. Without going into too much detail on this, many of you would have been aware of password manager apps, and there have been numerous security challenges, in particular with the master password, or when you actually still need a password to unlock the app that manages, for example, a large collection of passwords. And if they're cloud-based, this is a major security issue. So my approach is to actually take this whole concept contactless. So simple tap to log in, make it batteryless, lightweight, waterproof, and low cost, and relying on cryptographic protocols and near field communication. So to explain it in simple terms, I'd like to use the key analogy where you have a traditional door or car key that you just put in and open up the door. And I'm fundamentally building an electronic equivalent to this, where you have an electronic key and an electronic lock, and allow integration into a so-called authentication framework. So Windows Hello or the Windows platform provides a unique opportunity to enable other methods as a service.
Robert, just last 1 minute.
Okay, good. Still going forward. So from a research gap overview, it is certainly the crossover between usability, security, and privacy. And in terms of security, one of the main challenges is what happens if you lose the magic key that unlocks everything. And insight so far that I gained from initial experiments is that distance matters a lot. From an uptake perspective, it's driving down the costs, which is an engineering and mass production issue, and usability is extremely critical. Don't want to go into too much detail, but fundamentally with NFC, you transfer energy, for example, to a contactless card or chip. The reader or the device is then able to read a command. In response, the card sends out a message, and then further actions can be taken. So my work largely concentrates on the steps 2 and 3, where there are various commands as part of the protocol. Work that I'm analyzing. Okay, I'll wrap it up here.
Yeah, because we have another presenter, and thank you very much. It's very interesting work. I'm sure we'll be all here up to the presentation and breakout rooms to discuss further. Thank you. And I hope you have a safe journey.
Thank you. I hope too.
Our next presenter is Domingos Mondego.
Yes.
He will present on the use of artificial intelligence to enhance user satisfaction in cloud-based payment system in Australia.
Yes, thank you so much for having me, for giving me the opportunity to present today. I'll try to be brief, try to present or fit my presentation in 5 minutes. So I start with my research topic is the use of artificial intelligence to enhance the user satisfaction in cloud-based payment system in Australia. And this is the outline of my presentation today. What is satisfaction? By definition, satisfaction is a pleasant feeling that you get when you receive something you wanted, or when you have done something you wanted to do. So in business, the term user satisfaction refers to people's sentiments, attitudes, and expectations in regarding to the perception that they have received an outstanding services. But why do I need to study, do I need to go through this user satisfaction? As you can see here in this table, despite all the benefits of using the digital payments nowadays, which we are going to talk in a few minutes, the number of people using these services are still low. So in 2019, so before the pandemic, the number of Australians using mobile payments, for example, was only about 19% of the Australian population. This might indicate that they are not satisfied with the current payment systems, or they do not know or don't know the benefits of using it. So the aims of my research projects are to identify how artificial intelligence could improve user satisfaction in cloud-based payment systems, or CBPS, and to develop a framework that can be used as a strategic business guideline by organizations. Also, the aim of my study is to answer these research questions by comparing and contrasting different services around the world, investigating and analyze consumers' spending behavior, and finally present a guideline for all organizations involved in the CBPS in Australia. So this is an overview of the evolution of payment systems from bartering or from exchanging goods to digital money. We have seen that people are using less cash and more digital means of payment. So however, with this evolution, the simple act of paying bills become more complicated because we are using more digital IDs, passwords, fingerprints, and so on. Also, we have been producing so much data, so much information that we need to get a different approach to store and access data. So cloud computing emerged as the method and or technology that allows people to store and access data over the internet. Cloud computing has proved to be a better option for organizations to boost their capacity to handle data, enhance levels of mobility, agility, and scalability, control large data storage, and manage software applications. Also, as a cloud computing emerged and the technology for payments has improved, the natural path is to adopt any digital payment conductor over the internet. So in this context, the CBPS has been gaining momentum because it allows payments to be made from mobile devices or through bank transactions over the internet. However, despite the evolution of the technology and the emergence of the cloud, there is a need to develop smart machines that can process and analyze large amounts of data collected from the internet users. So in this sense, artificial intelligence or AI has emerged as a solution to deal with this issue, as it quickly recognize, process, and learn from patterns in the data. As many people still think that AI is a technology that will be adopted in the future, but in reality, the reality is that the AI is already present in the people's daily experience. For example, it is present when you start typing and Google autocomplete text fields. So in solicited recommendation of making searches on Google or Bing, musical suggestions based on listening history on YouTube. So AI technology is already being used by all of us on an everyday basis. So, but how can it be used to enhance user satisfaction? A good illustration of how AI could be used to improve services is that 85% of Australian consumers are willing to spend more for services received if organizations provide a better experience to them. By providing a better experience, we can say that improve their level of satisfaction with goods and services received. So AI can be used as a tool to make better decisions or predict user behavior, and they can be used to detect fraud in bank transactions or detect patterns in users' behaviors and so on. In order to collect and analyze data, this study will use a combination of quantitative and qualitative research methods, which will be divided in 3 stages. The first stage will be secondary analysis, the second stage online surveys, and the third stage semi-structured interviews. And the expected outcome of this research project is to contribute to the current knowledge in digital payment sector by providing guidelines to stakeholders in the CBPS, to general knowledge in information system business management, or specifically in the use of AI to improve user satisfaction in CBPS. And finally, this study will investigate and point out future trends in the cloud-based and emerging payment systems. Oh, that's it. So that's it, guys. If you have any questions, just let me know.
All right. That concludes the session, and I'm sure we can have discussion afterwards because this session should 15 minutes break time. I'll pass over to Marlene.
Thanks, Ray. I was actually going to suggest that we cut this session down to 5 minutes just so we can stand up, walk around and grab a coffee or tea. And then when we come back, I have the 3rd session. And at the end of here, I'll then open the breakout rooms for 30 minutes so we can keep everything on track as much as we can. Okay? So you have 5 minutes and then we have the 3rd session. Thank you. With you. Thank you.
Okay, thank you very much. In this session, we have 5 presentations. 3 are in the broad category of teaching and learning, and 2 are in smart farming. So 5 minutes each, and that would leave us 1 minute each for question answer, maybe 1 question each. So first presenter is Gopi. The topic is incorporating blockchain technology for smart and sustainable farming. So Gopi, when you are ready, just share your screen and take it away. Thank you.
Thank you. Good afternoon, everyone and everything. My name is Gopi Akella. Today I'm going to give a presentation on my research topic, which is incorporating blockchain technology for smart and sustainable farming. And I actually improve the value chains and minimize the intermediaries using dApps, decentralized applications, and smart contracts. My supervisors are Dr. Santoso Ibowo and Dr. Sriman Granthi. In our preliminary research, we identified that the agriculture supply chains are complex because they lack of transparency, trustworthiness, and tracking and traceability. The problems are because the existing systems, they are good as long as they provide the supply chains, as long as the transactions are happening, but they fail when there is any food sabotage or any food safety concerns. Like, for example, recent cases we've seen E. coli virus, and also somebody placing nails and needles in strawberries. So in order to trace back, in order to track the origin of that sabotage, of that incident, it's very hard. And also consumers would like to know the origin of food, where the food is coming from, they consume. So like not just relying on the label, whatever the vendors mention on the labels, like this product is from Thailand, for example, or this product is from Australia. So consumers cannot trace back whether it is really coming from that location or not. So these systems, the existing systems, fail because they are centralized, and we have to believe whatever the vendors say. And also, like, since I said, like, for example, there are organic food, and they just mention on a sticker that this is organic, but we cannot trace back, we cannot track whether it is really organic or not. And also there are a lot of intermediaries involved in agriculture supply chains, and these intermediaries have lack of transparency. That is one issue. And another issue is asymmetric information. Someone has more information, someone has very less information, like that. So these are all the challenges that the existing agriculture supply chains face. And a lot of people, a lot of researchers have mentioned that blockchain could be a good technology. Besides, it has been a very good technology for finance industry. We've seen Bitcoins and others, but it supports agriculture as well. So what we thought is we are going to see how good blockchain technology is for smart farming and sustainable agriculture. But before we discuss that, let's see what is blockchain in short. Blockchain is a distributed ledger which stores encrypted information in blocks, in the chain of blocks, you can say. So each encrypted information, each transaction is stored in an encrypted format. And these transactions are time-stamped, so no one can tamper with the data in each block, in each transaction. And also on a blockchain network, all participants will have a copy of transactions. So if someone wants to tamper with the data, that person has to tamper with the data of all blocks with, all participants having those blocks, which is very hard. So that's why blockchain is a decentralized and fraud-proof. It is reliable and secure because it is encrypted data. There are a wide variety of blockchain networks available, like public, private, permissionless, like that. So you can have a public permission network or a private permissionless networks like that. And also we can deploy applications using smart contracts. We can use JavaScripts like React.js, AngularJS, Web3, like that. We can develop these decentralized applications. So what we have noticed in our research is the current research is still in infancy stage. A lot of researchers proposed blockchain technology for agriculture. And there are some applications available which are based on food provenance and trust. But again, when it comes to food provenance, it is for consumers, not for farmers. So what we are going to give to the farmers, why farmers join blockchain or why farmers adopt blockchain technology if they are not going to get any benefit. So our research project aims to address the gaps like this, to identify a solution for the challenges that we have discussed earlier. There are so many, I've just covered a few of them, like trustworthiness, transparency, and asymmetric information, etc.
One more minute, Gopi. Sorry.
I'm coming to the point. So to identify a decentralized system and develop a blockchain protocol stack, and to develop an architecture for a decentralized system. So research gaps, and we are going to find answers for these three questions, like what are the challenges associated with agriculture value chains, and strengths and weaknesses of existing architectures, and how is it possible to develop a blockchain architecture. So for this, we have adopted systematic literature review technique using Prisma technique. Why Prisma? Because the research requires an in-depth review of peer research. There is a lot of research available. So we are going to see, do an in-depth review of them. And to formulate a foundation for developing an architecture, we need it. And for that architecture, we need very clear, valid, and auditable data. So we are going to do a meta-analysis to draw reliable conclusions. So we need Prisma technique that will help to draw reliable conclusions. And my COC is due actually to submit. That's why I've developed a framework, but not showing it because it hasn't been submitted. I've submitted a conference paper and working on 2 CIS projects, one on academic transcript verification, and the other is food provenance application. First one I've developed, second one in the process. I'm going to finish it, which covers 50% of my research. And also I'm working on a journal. Okay, I'm ready to answer questions. Thanks for your time.
Thanks so much. We have time for one question. If anybody has any questions, please.
All right, I will ask one. Gopi, sorry, I missed first part of your presentation, but knowing your research, because I was one of your other presentation, was the implementation of this blockchain in a farming applications, because farming pretty much open-ended. They don't care about really security. So blockchain is heavy. It will essentially add cost. I'm not saying it's not, there is implementation, but I'm just asking what is the motivation from their point of view, because in a farming application, farmers are not much worried about if their sensor data gets to be hacked by anyone.
Of course. We're actually not looking at, like for example, smart farming requires a lot of IoT. That's there the security part comes into. I'm talking about farm management and agriculture supply chains. So there. And also coming to the cost wise, we are not asking farmers to develop this one. We can develop an application and farmers can just use it like an application from their mobile phones. And also they can integrate the smart farming part of IoT and that stuff to blockchain.
Thank you.
Thanks.
Thanks, Gopi. Our next presenter is Ken. Ken's topic is about ICT and engineering course assessments beyond COVID-19. So Ken, when you're ready, please.
Thanks, Jahan, and hello, everybody. I'll just set up my screen share. Portion of screen. You don't see anything just yet, but be patient. And I'll just, oops, sorry. I always use this screen portioning technique because I just find it really handy. Am I on? I mean, or rather, can you see my slides? Hello?
Yes, Ken. Yes.
Okay. In this slideshow, I'll just give you a very brief idea of what my relatively fledgling thesis I've just started not long ago, but this slideshow should give you a good idea of what it's all about or what I'm trying to do. I'm looking at the issues with assessment in higher education. The issues you see that I've got listed there are all intimately associated with assessment, even though none of them might be directly. They're, for example, some of them are symptoms of poor assessment, poor assessment modeling, and lead to surface learning approaches, for example. Some of these things point to dissatisfactions which may be partly caused by the nature of assessments, such as non-alignment issues, which are known to lead to dissatisfaction with assessment, and which in turn can contribute to problems like attrition. Some of these directly impact assessments, obviously, such as academic integrity. Some of them may not be directly part of assessment regimes, but they're becoming so critical to the perceived mission of higher education that more direct assessment models may be required. One of these, for example, is graduate attributes. The COVID-19 interruptions have forced some key changes in assessment design and delivery. And so that makes this a sort of an opportune time to revisit assessment theory, practices and models, and to try to devise one that addresses many of these concerns. This will have significant benefits in helping to guide the direction of assessments through the uncertainties of the post-COVID world. This is my grouping of the major theory groups that contribute to this thing. Alignment theory is a big one, as is constructionism, and there are two broad changes in the nature of the university cohort that kind of leads to problems in alignment as well as in constructionism. And basically these two are the fact that uni students are much more diverse than they ever used to be. And secondly, the majority are non-academic in their purpose or rationale in coming to university. And these two realities have fueled a lot of the known challenges in learning, teaching and assessment. And it's also given fresh impetus to established alignment and constructionist theories of learning. As an example of something that comes out of behavioral learning theories, there's the concept which has been called backwash. And this is the observed behavior that students only learn what they think will be assessed. And that behavior directly feeds into or leads into surface learning approaches adopted by many students. So we may carefully design our curriculum to be comprehensive and balanced, but to some students, the true curriculum goes no further than the content of available past exam papers. And of course, making this picture even more complex are a number of more contemporaneous factors like the ones listed. For example, graduate attributes have become much more critical in university outcomes. They're no longer just a list of, hey, look what else our graduates can do. And yet the matter of exactly how graduate attributes should be measured, quantified and recognized is still quite unclear. So these gaps have developed, and in essence, these gaps between reality and current assessment models are the gaps I'm aiming to step into and investigate more fully. So my research aim, can I design an assessment model that holistically addresses major challenges that have emerged by treating them as components within a sort of a revised assessment system? So I have 4 research objectives.
1 minute, please.
Okay.
1 more minute, thanks.
Okay, number 4 there would be the one that's most cogent for us here, leading to my 5 research questions, but I'm anticipating to chop that down to 4. And my proposed conceptual research framework here gives you an idea of what I'm trying to aim at, a developed comprehensive assessment model, which I'm expected to be able to make a contribution and provide some significant contribution to this conversation. So both of these promises are best effort at this early stage, and I'm expecting they'll inevitably evolve as the main literature review matures, because that's really only just started. That's it. Questions? Or question, I should say.
Any questions for Ken, please? Doesn't look like, but very intriguing project, Ken. Look forward to your findings. Thank you so much.
Thank you
for sharing. Our next presenter is Dona. Her topic is on the social media marketing in harnessing international students to Australia. So Dona, please share your screen. Are you here, Dona?
Yes. Hi.
Hi.
Let me share my screen. Can you all see my screen?
We can. If you can go on the slideshow mode. Yep.
Yep. All right. Okay.
Thank you.
So thank you so much for choosing me for the Research ICT Symposium. I'm Dona Pranawithana, and I'm in my second year of my study for social media for Australian University. So my main aim is to kind of bring forth the components of social media and connect it to Australian universities and how universities in whole can enhance the to market as an education students. So my research topic in detail would be the influence of social media marketing in harnessing international students to Australia, a digital framework to assess the value in higher education market. One of the major reasons why social media has become the new hype for the world in terms of getting information, buying, and even selling. And also it has become the turning point and the central point of contact for marketing. The marketing world has completely swirled around this social media in the past few years, and it's growing ever more with this COVID. Also, the fourth largest revenue up to date, I have statistics that I will show you later that shows even to date, it shows that international students are the fourth largest revenue export product of Australia to the Australian economy. And social media marketing is inconsistent, and it needs to be looked into, especially in terms of the education and how universities look at their marketing proposals when it comes to attracting more students. When we compare ourselves to huge markets like US. And also attracting and retaining students have become really difficult. With myself as an international student, I find that there are so many opportunities and alternatives available that we need to look into these things, why and how we can keep them. And as predicted by scholars, it is expected that social media will be used by 4.1 billion by the year of 2023, with a 92% of people accessing the internet from their mobile devices, and it's ever growing. I'll just these statistics. As you can see the amount of Facebook followers, which is, I hope you can see this. Yep, it's 381,794 people following. If you can see the reactions, the number of comments, it's just growing, ever so growing. some things even grow, especially the younger generation is so inclined towards Facebook. So this is a great tool to understand what and why and how we can market our universities. Moving on, the main research objectives. The first objective is to identify the decision-making patterns, the attitudes, the subjective norms, the external variables of international students that link to the factors why they are making these choices. How they decide. The second one is students, the literature gap in finding the best practices in making a digital university promotion campaign successful. Needs recognition, information, search, and evaluation of alternatives. This is a real huge gap that I have seen in the Australian literature in terms of connecting marketing, social media marketing. And there have been small studies done, but not in a scale that we have enough resources.
Sorry, Dona, you need to finish up soon.
Yep.
Just
All right.
1 minute, thanks.
Yep. And the next one is to find a common framework that can be monetized in the higher education sector, and how Australia can gain worldwide recognition as one of the best destinations to study. So when you talk about the contribution of the study, academically, well, the study aims to attract prospective international students, which is obvious. And the next one would be the economic development. As the Sydney Morning Herald published, it's still the largest export in the country, 4th largest. The methodology I will be using will be the survey method to understand how, because we're trying to see how people get into a platform where they read and understand. So survey is the best way to understand who will come, why they will come in that form. Just quickly get all the information down. Okay, so structure.
I think we have to finish, Dona. Sorry, we are running out of time. So if you can summarize.
Important information for the research that research is going to, especially due to the COVID-19 situation, I think it's really important for the universities in total, and especially for the Central Queensland University. Why I'm doing it will give out a digital framework to pursue marketing much better. Thank you.
Thank you very much, Dona. I think if you have any questions, could you please write in the chat box for Dona? So Dona, please keep an eye. We should move to the next presentation because we have 2 more, starting with the next one. Next one is from Tej Bahadur. The topic is on peanut disease detection using UAV images. So Tej, whenever you are ready, please just share your screen and take it away. Thanks.
Thank you, Jahan. So good afternoon, all. So do my slides visible to you? Is this okay? Yep, thank you. Today, my topic is disease detection. So using multispectral imagery. So this is the case study on peanut disease. So my supervisors are Professor William, Dr. Arjun, and Dr. Zhu. So let's start. So this is the outline. I will introduce my topic and then what sensor we are going to use, and then study materials, few preliminary results, and conclusion, future work. So the motivation behind this project is like disease assessment, if done manually, will cost both labor and time. So whether that can be replaced with drone or UAV, having multispectral or RGB or hyperspectral, even hyperspectral sensors. So this may be the quite good candidate for automatic disease scouting and disease ranking. So this is the figure here shows the drone accessing the plant health scouting. So drone are much useful in various field of precision agriculture, as you can see. So the sensor we are using is the multispectral sensor that can capture the information beyond the visible light. So the visible light is very thin here on this range. So we are trying to use infrared spectrum. In our sensor, we have 5-band image like blue, green, red, red edge, and near infrared. This is the MicaSense red edge sensor that we are using in our drone imagery. So here we can see like blue, green, and red visible spectrum. There is no much significant differences among the healthy and the disease peanut plants. But when we move to red edge and near infrared, we can see a little bit differences among the healthy disease plant. So to utilize this significant difference, we are proposing to design an index so that we can combine these 5-band image into a single index image for further analysis. So for example, this is one index, that is the normalized difference ratio between near infrared and the red edge band. So we are planning to experiment few more indices for better model search. So which indices will perform best, we will select the one. So for this disease detection, we are not only trying to identify healthy and disease plant, but we are trying to experiment how early we can identify disease. So we are capturing image at the different days after plantation, like 43 days after plantation of peanut, we capture one image, then after 1 week another image, 1 week another image, and similarly until the peanut harvesting. So these are the index image, near infrared and the red edge normalized difference index image that I have shown in the previous slide. So for the illustration sample, I have put here a few disease plant and the healthy plant. Like these are the low disease, that means the disease is not so high, like this can be considered comparatively healthy plants, and these are the highly diseased plant. So when this plant grows up, then maybe in any stage disease can appear. But what we are trying to do here is whether we can predict disease early during the growing season. Like if disease appear from here, then visibly that might be visible only later on 1 or 2 weeks, but that might started from here. So we are trying to capture the information with multispectral imagery so that we can predict disease, identify disease as early as possible. So for this, we are trying to design a threshold that can differentiate between healthy and the disease plant. So that will be carried out using the pixel level information, like we are counting healthy pixel and the disease pixels. For this, we need to find out a threshold. For example, in this picture, we can see this 0.7 index value can be used as a threshold, which is clearly separating these disease pixel and the healthy pixel. So from this information, we can design a model that will identify disease versus healthy pixels. So
thanks, Tej. Wrap it up if you can.
Yep. So this is the initial prototype. So we are trying to get into more indices so that which one better separate, and then we are trying to link those disease score to final peanut yield, because we are finally interested in estimating the peanut yield, how much disease is affecting peanut yield, and which varieties of peanut is most affected by these kind of disease, and which peanut variety is most resistant to the disease. So that is our future work, and we probably build the artificial intelligence model for that kind of things. Thank you. So these are the references. So if you have any questions.
Thank you, Tej. Any quick question?
Yeah, I do have one, Jahan. Thank you, Tej, for presentation. Just a quick one. You said you were collecting image by a drone. Am I right?
Yeah.
And that is offline, meaning it's not real time. You go send drone, get image, process.
Yeah.
But there is quite a bit of change in the context of agriculture within that period of time. And that means what you are deciding may not have any impact when your decision is made, especially if you're talking about the different growth and the agricultural change. So did you think real-time processing of those machine learning in the drone while it's getting collected?
Yeah, that is possible, but for now we are just interested to identify or to rate the disease level, so that can be done offline, because once we got the imagery, then we can it's called manual disease rating. Like we go to field and once in a week we collect some samples and then we rate the disease. So for this we can do offline, but for real-time plant health monitoring, that is possible, because now we can find edge AI devices that can be easily integrated into drone. So like a small kind of edge device which can run machine learning algorithm as well. So that is possible, but in our project we are doing offline image processing.
Thank you.
So can I quickly jump in? Because when we want to train the machine learning model, data doesn't have to be real time, but when you're detecting, it can be real time. So that is mainly the point. Thank you.
Yep. Thank you. Thank you for adding up.
Thank you. We move on to our final presentation from Kaixiang. Kai's topic is on developing an online examination timetabling system using artificial bee colony algorithms. So, Kaixiang.
Yes, I'm here. Thanks. So, shall I start? Okay, let me share my screen. Here it is. Okay, my topics, that one it has been already introduced. And I'm a master degree student, and my principal supervisor is Dr. Lily, and my associated supervisor is Dr. Michael Lee. And before that, I'm going to introduce some background of my research. And my interest is about the educational timetabling, because that is the fundamental problems in every schools and universities. And also this topic has been studied for over 15 years, but it still has been very popular today. And the reason I chose this topic is because now we are infected by the COVID-19. So the COVID-19 also changed the way we our teachers to teach and the students to study. And I believe that in the educational timetabling problems, the examination timetabling problem is the one which has been affected by the COVID-19 the most. And my research aim is to provide a computational intelligence solution for that challenge. And what is the educational timetable problems? It is to allocate a number of activities to the time slot or room slots. And each activity has its conditions and needs to be satisfied. And those conditions can be categorized to be hard constraint and soft constraint. The hard constraint ensure the solution is feasible, and the soft constraint is to provide a more better solution. And the educational timetabling can be categorized in many ways, but I just chose this way to explain them. It can be divided to be course timetabling, school timetabling, and examination timetabling. And the course timetabling is to allocate the teaching resources such as the time, classroom. It is to ensure no students can take more than one class in in the same time, and the school timetabling is to allocate the teaching staff to and also consider their availability and their specifications level. And the examination timetabling is to ensure no student can take more than 2 exams at the same time. And because of the COVID-19 this crisis, all of the teaching activities have to be moved to online. And for the examination timetabling, it has more unique constraints because of this situation. And there's the constraints, and those are obvious. One is the examination are not invigilated, and it is also open book. And the period of the exam, one exam, it can be extended up to 12 hours, not like it before. In almost normally, one exam only can last for 2 hours. And also because the exam there's no room capacities, so we can house as many as students in one examination hall as possible. But also because there's no room capacity, so the exam can be the number of exams that share one time slot is unlimited as well. Based on the scenario of Security University, I propose this conceptual model. Firstly, we will retrieve the student enrollment data, and then we'll generate a exam conflict table. I will mention that later. After that, we will input some parameters such as the durations and the number of students and the length of the whole examination week. After that, I will apply the ABC algorithm, which is the artificial bin colony algorithm. And after the running of this algorithm, a group of workable solutions will be outputs. And then the filter, which is related to the soft constraints, so will be put to those solutions to find out the best solution. That is the model. And in the okay, in the education timetables field, there are multiple algorithms that are used. And now I chose the ABC algorithm to put it inside. The ABC algorithm is the population-based meta-heuristic algorithm. It has 4 features. It has the positive feedback to ensure the solution can be found as much as possible, and the negative feedback to avoid the solutions. The one spot of the search space have been explored too much, and also the frustration to ensure there are more creativity. Okay, that is the mechanism of the ABC algorithm. We will populate multiple bees to the area of this search space, and each bee will search its neighborhood area randomly. Once if for example, this area has been explored too much, then this area will be abandoned, and the bee will be transferred to the scout bee for the new area. That is the basic concept. And I modified this ABC
I think
algorithm.
we have to wrap it up. So if you can summarize your project and finish up.
Okay.
Thanks.
Okay. I just okay. I can show the result of this application. And also I compare my modified ABC algorithm to the constraint programming, and the result shows that this ABC algorithm can solve the online educational timetabling problems, and also it can provide a feasible solution in a very quick. You can provide this solution very quick. Sometimes they also use this 4.1 milliseconds. And also this algorithm can rank the search space. And this algorithm, I proposed I changed the neighborhood search process so it can avoid the over exploration. And so far, my process of my study today, I published one paper, and also one of my paper has been accepted. Okay, that is the end of my presentation. Thank you.
Thank you. Thank you so much, Kaixiang, for your presentation. So that brings us to the end of the session. But before we go, questions for Kai or even Dona, please. We didn't get to ask Dona questions, so if you have any, please go ahead.
I've got a question for Kai. So Kai,
yes.
I know that ABC algorithm can give you a solution, but how do you know that the solution is the best solution? So there can be a better solution that you have got from ABC algorithm.
I cannot say it is the best solution, but I compare the ABC algorithm to the constraint programming is better than that one, because the constraint programming is the traditional programming, and ABC is better than them. And also ABC algorithm is not supposed to find out the best solution in the search space. It's to find out the better solution, because the search space is too big. To some extent, it is impossible to find out the best one. But we just try to find out the better one, and in a limited of time.
Thank you.
Yes.
Any questions for Dona at all? All good, no questions. That means I'll hand over to Marilyn. But Marilyn, it was so good to see some of my undergraduate students attending today. I saw them attending, and it's so good for them. Somebody messaged me as well that they were very happy to see the presentations. Anyway, thank you. So over to you, Marilyn.
Thank you. We've got about 31 coursework students from both postgraduate and undergraduate students attending today. So that's very, very good. I just wanted to do a quick wrap up before I hand over to Steve Moore for the final wrap up. Over the next day or so, I'll be sending you out feedback forms. So if you could send those back as soon as possible, that would be really good. I think we did very well today. So therefore, see you same time next year.
Not on Zoom.
Third thing, take your cameras off. I want to take a shot. I want to take a screenshot.
Thank you for organizing this, Marilyn.
My pleasure. How are we going there? I think we've got the best we can do. Done. And now I'll hand over to Steve Moore for the final wrap up.
All right, I don't think I need to wrap up. I think I'm more to say thanks, Marilyn and the team, for putting this together. I think a lot was, I had to duck out for a while for another meeting, but definitely a lot of ground was covered. Particularly like to thank the RHD students for presenting. That's always great. And there was a few, I guess, because we haven't really had a chance to do the in-person RHD seminars for what, 18 months or so now. It's good to see there's a couple of projects that I wasn't personally aware of, so it's always good to see the activity that's happening. So also like to thank the people, the moderators and the chairs for the various sessions for keeping it going. I think we're getting pretty good at these bloody giant Zoom meetings now. I have to say I'm totally sick of it. These headphones just kill my ear. A full day of Zoom, and it makes me feel terrible. So on that note then, because everyone else is probably feeling pretty tired, just thanks for attending. And I think for me, bottom line is, in terms, especially like the mentoring, there's a lot of people out there that I probably have never had a chance to have a one-on-one with. Just contact me if you want to ask questions about applying for a grant. As Christine mentioned, the internal grants is going to open up this week. We didn't have any applications in the last round. I was on the panel last week doing the assessments. $15,000, and it's not the new staff grant. It's open to anybody. So you should get an email about that. I'll probably forward it on to the whole school when I get it. So let's get some applications in for that. But yeah, if you want to, if you have questions about doing research, especially if you're an early career researcher or a new staff member, or you've got issues, just contact me directly. That's the best way to do it. And I think on that note, I'll stop there and just say thanks and have a great evening.
Okay, thank you. And for one last thing, I'll just open the breakout rooms if you want to get together and have some chat. Where we didn't have the time earlier on, they'll be open for 30 minutes and then they're closed. Enjoy the rest of the day.
Thank you. Bye.
Bye.